Namaskar, my dear friends. Let us talk about image processing in MATLAB. So what are the things that we will do in this particular session is, we will understand how to read an image using MATLAB coding. We will change the image to grayscale image so that you can have understanding to change a colorful image to grayscale image. We will also learn how to apply different kind of noises, like we have salt pepper noise or Gaussian noise, or there are so many other kinds of noise are there. So how to apply noise to the image. We will also learn how to apply the filter so that we can have a proper picture or proper image from a noisy image. So these are very good steps to learn MATLAB very quickly and very easily. So let's open MATLAB. What we can directly do is, as you already know, we'll just start with let's say image processing in MATLAB. Now the first thing that we always do is, let us say, clear the command history window. So we'll clear command window. If there are any like figure or something is open, we can close all of them, close all. So that is the good way to start with. If you are using your desktop version, you can put clear all also, so that you can clear the previous workspace variables and all those things. Now let's start the first thing. What we have to do is, we have to have a JPG image or BMP image, whatever image is there with you, that you can keep in the folder where you are working for this particular file. Okay, now we can start with, let us say, I is equal to, we want to read the image, right? So we want to load the image to the code. So what I can do is, the command for that is I is equal to, let us say, imread. Imread means image reading. Okay, so this is a command, and then we can give the name of the particular image that you want to read. Okay, so let us say my image file name is penguin.jpg. penguin.jpg. So this particular image has been read. Okay, now if you want to suppress this, you can suppress this by giving a semicolon, otherwise it will read out all those images in a numbers in this command history window. Okay. Now what we can do is, we can start figure so that we can plot that figure, plot that image into the figure window, figure. And I can show I am so, like I can give a command I am so, and the image name what I have given, this name you can give whatever name you want. This is a variable name that I have given as I, so you can put I. So I am so I will be given. Now why don't you do one thing, we can give a title name also, or let us say we will run up to this so that we will see what is the image that is coming up to our person, right? So go to editor, press run. So you are seeing that your image is shown here. So you can see this is the colorful image that is there from penguin.jpg, and this is the original image. So what, to identify this particular image, what we can do is, we can put a title to this, title, and then write down original image, original color image. Okay, so that's all. So this is done. Now if you rerun it, so the title will be shown here, original color image. Okay, now the next part that we want to do is, we want to change this particular image to grayscale image. Okay, so let us say we'll just put let us say j1 is the variable name we'll keep, and we'll put RGB to gray. This is red, black and green, red, blue and green, RGB, right? So red, blue, green, all the three colors are there, right? So in that case, we can put RGB to gray. Okay. So here you can see RGB to gray, RGB to hex, RGB to HSV, all these things are coming. Okay. So we'll put RGB to gray. And which is the image that I want to convert from RGB to gray? So this is the I image which we want to convert. So we'll put I. All right. So we have converted this. Now if you want, we can again put a figure I am so j1, and title we can write it down. So I'll just copy this one and paste it here itself. So figure, and then I'll put it j1, and then this is my grayscale image. Okay, so grayscale image will be shown. So if we run it, what will happen is, figure 1 will be shown as colorful image and figure 2 will be shown as grayscale image. So the colorful image has been changed to grayscale image by the command RGB to gray. So this is how you change from a colorful image to grayscale image. Now why don't we do one thing? We will just apply noise to this image. Okay. So let us say I'll just put a variable name to noisy image. Noisy image. Okay. So noisy image will be my name, and I am going to put IAMNoise. So IAMNoise is the command name or the variable or the keyword which is going to add noise to the like image that you want to add. So let us say this is the J1 image, which is the like grayscale image. I want to add noise to the Gaussian. So you can see it is giving an like a hint as well, like Gaussian and m variable Gauss. Okay, so if you want you can quickly do that. So J1 comma I'll put Gaussian. So I'll put Gaussian. Let us say I'll just make it this side. Now Gaussian. Okay. And then Gaussian variable, what we can do is we can keep 0, and then we can keep you like mean 0 and variance 0, and this is 0.06. Okay, variance 0.06 will keep. Let us say 6 or 5, whatever you want you can keep. And then again same thing, what we'll do, we can put a figure IMSO title, and we'll see what is the noisy image that it is shown. So this is how you are able to now recognize or understand how to add noise to a particular image, and then what will be my mean and variance that you can put based on your understanding or your choice. And I am going to show the noisy image here, noisy image, and this will be my uh, noisy image. Okay, understood? Now let's run this, and what we'll see, we will be able to see here that this noisy image will be shown here with a lot of noise using the Gaussian image, right? So this Gaussian noisy image will be shown. So let's run it and see what is happening. So this is my figure number 1, figure number 2, figure number 3. So you can see figure number 2 was grayscale image, okay, and this grayscale image has been converted to noisy image. If you want to reduce the noise level, you can do one thing, you can just reduce this value to, let us say, 0.3, and let's see what is the image that is coming up. So little less noise is there. Now our aim is to convert this noisy image to a better image by applying some filter. At the same time, why don't we try one more thing? We have help here, help IAMNoise. So there are a lot of like noise list that is there that you can try to apply to your like image. So you have Gaussian noise with general function, then m variable. So these are the three things that you can try. By default it will be taking 0 mean and 0.06 variance, like that it will be see 0.01 variance. So this is the default value. Okay, similar to that we have local variable noise, we have Poisson noise, we have salt pepper noise. So let us try with salt pepper noise. Okay, so what we'll do is we'll just copy this and paste again. Okay, so IAMNoise, I am going to add here salt and pepper noise. Salt and pepper noise. So salt and pepper noise requires only one variable. Okay, so if you want you can give it, otherwise you don't need to give. Okay, so that will be salt and pepper noise, let us say 0.05 we will keep. Okay, so I'll just keep this one as commented, so this will be commented. Okay, now let's run this. So as you can see, the salt and pepper noise looks like, see, this is my original image in grayscale form, and this is my salt and pepper, so salty image it is looking like, right? So little bit salts and in sprinkle is there. Good. So now what we can do is we can apply filter and try to see this salt and pepper noise, like this salty image can be converted to a better quality image. So this is how what we have done. We have original image which was very good blue RGB color, like colorful image. we have converted to grayscale image, then we have converted to some noisy image, and again we are going to convert this noisy image to a filtered image with very beautiful figure. Okay, so how to apply filter? So let us say we are going to apply some median filter. All right, so in median filter what we can do is median filter. So in that case, what we can do is, this is the comment I am giving here. So I'll just take 3 cross 3 median filter. So I'll just put m equal to 3, n equal to 3, so that like I can give a size of m cross n, and then I can get filtered image, okay, or I can give filter image, okay. So that will be the name of my variable. Now to give the median filter command, we have mid filt 2, okay. And then what was the image that we want to apply this filter to? So my image was noisy image, so this variable I can take it as noisy image, and then I want to apply median filter to this guy, right? So m comma n. So this is the command that we are going to apply. Now we have filtered image. So this filtered image, again we can show it. So I can just plot this figure. So again one more figure window I am going to take. I am going to show the filter image here, and then this will be my filtered image. Okay, so we have original image, grayscale image, noisy image, and then we have filtered image. So you can see, let's run this and see what is the filtered image that is coming up after noisy image. Okay, we have some problem here. Let me just check once. It is saying image processing invalid expression when calling a function or indexing a variable, use parenthesis. So there is something called like use parenthesis that it is telling you. So yes, we should not use this one. We should use big bracket. Okay, so this one we should use. So just make sure that it is coming into the square brackets. Now let's run this. Okay, so as you can see, it is running. Once it runs, it will give you the filtered image, and you will be able to see filtered image is very beautiful. So what I will do is, this was my RGB image, grayscale image. Okay, sorry, this is my grayscale image. Then this is my noisy image, and after noisy image we have applied some median filter, and that median filter is giving me very beautiful picture of the noisy image. So as you can see, we had applied it on noisy image, and it has changed it to filtered image, which is very beautiful. Okay, now there are some other parts, like let us say we want to design our own filter and apply it. So let's say we will design some high pass filter or low pass filter, and we'll try to do that. Okay, so let's say we'll just do filter design. And filter design, you can design your own like coefficients, just like this median filter was designed for 3 cross 3. So this has inbuilt values of median filter, and it is taking those parameters automatically, but those values we'll try to give by ourselves. Okay, so what we'll do is, we'll try to give image I mean this filter design as like this. These coefficients will be, let us say, 1, -1 and 1, then -1, 1 and -1, and then 1, -2 and 1. So this is my filter coefficients that is designed. Now I am going to do this high pass. This is high pass filter coefficients. So this high pass filter coefficients will be applied to the noisy image, and we will be able to see what is happening. Or maybe we will apply this particular filter to the grayscale image, and let us say this grayscale image will be converted to high pass filter. Okay, so let me just copy quickly here so that I don't take more time to write down all these things. Now I can put it high pass filter image. Okay, so high pass filter image, I can put here convolution. So this will be a convolution operation. Okay, so convolution operation on grayscale image. So grayscale image, what you have to do is, You have to convert that grayscale image into double form, double J1. Okay, so J1 was the name of that figure, right? So J1 was the name of this figure, RGB image, right? So we are applying on that. Now we'll put here double H1. Okay, so now you are very clear, like this H1 will be applied, this particular high pass filter coefficients will be applied on the double values of RGB, this grayscale image, and it will be shown. So I can show here high pass filter image, HPF, and this is my high pass filtered image. So let's see, this particular grayscale image will be seen high pass filtered image. How? With this high pass filter coefficient, you can design your own filter design and try to do this convolution operation and try to see. So let's run this. All right, so what you are seeing here is, you are seeing my grayscale image. This was the grayscale image which has been converted to high pass filter image. Okay, we can do one more thing. This particular high pass filter coefficient, we can change it to, let's say, some other values. So why don't we do one thing, we'll just do it, let us say 1, -2, we'll put it here, and we can keep all the middle values as -1, -1, -1, and let us say make this as -1. Okay, so first one I have made -2, and now apply it. So this high pass filter coefficients will make it very black. So this is how this particular image is looking. So this was the image that we had started, and this is the image that we have landed up after high pass filter. So hope you have a very good understanding about how to do this high pass filtering coefficient analysis, or how to design a median filter to remove the noise, or how to add a noise on a particular image, or how to convert the colorful image into RGB, for RGB to gray image. Okay, and how to read an image. So if you do have any questions regarding the image processing, and how, if you have very particular questions about what are the things that we should apply during the image processing, you can put down your questions in the comment box, and we shall be able to give you an answers. Thank you.